continuity is a big topic in limits. However, it is not that hard to study continuity. So let me give you a brief introduction. When you are talking about continuity, three conditions must be satisfied. Number one, f of a is defined. That means you draw a solid point on a graphing paper. And then number two is f of the limit as x approaches to a of f of x exists. Alright, so that means we have two curves, one on each side of the solid point are coming toward the solid point. So take a look at the graph on the right hand side, so right over here. So f of a is defined, so that means we have one solid point when x is equals to a, y is equals to f of a. So that is a solid point. And then number two, the limit exists. So x approaches to a from both sides. So as x approaches to a from the left, so take a look at the orange curve as x approaches to a from the left, and then as x approaches to a from the right, they are coming toward the solid point. So how do you express x approaches to a from the left? So take a look right here. So limit as x approaches to a. Do you see that I use a little minus sign? The minus sign means left side, or you can call this left limit. So as x approaches to a, f of x is equals to f of a, and then the right side as x approaches to a from the right, the little plus means the right side of f of x that is equals to f of a. So they are equal to f of a. What is that means? You have two curves, one orange and one purple, and they are coming toward the point and they must join at the point. Alright, so that is number three. The limit of f of x as x approaches to a is equal to f of a. So that is condition number three. Both curves meet at the solid point. So let's draw a new picture. So I have a graph down here. So let's draw a picture. So number one, f of a is defined. You just draw a point. So let's just draw a point like right over here. And then when x is equals to a, y is equals to f of a. So this is a solid point. And then number two, you need to have two curves, one on the left, one on the right, and they are coming toward the point. So on the left hand side, you can do this up and down, and then join at f of a. And then what about the right hand side? The right hand side, you can draw a half parabola like that. So as x approaches to a from the left, so look at my cursor. So as x approaches to a from the left, the limit equals to f of a. As x approaches to a from the right, so check out my yellow dot. As x approaches to a from the right, the limit is equals to f of a. So you have a solid point first. So starting with one solid point on a piece of paper. And then on the left hand side of the point, you have a curve coming toward the point. And then on the right hand side of the curve, you have on the right hand side of the point, you have another curve coming to the point, and the two curves and the point, they join at the same spot. So that's how you show that a function is continuous when x is equals to a. The easiest way to describe continuity is you can sketch the entire curve without picking up your pencil. So right over here. So let's say you have a piece of paper. Just do this very quickly. So is this continuous? The answer is yes, right? I sketched the entire graph without picking up my pencil. So how about this? Let me give you one more example. How about this? So one, and then stop, and then you draw an open circle, and then you keep moving. Is this curve continuous? The answer is no. The curve is not continuous at the open circle, or you can call it the empty circle. And then how about this? I have a function, so how about f of x that is equals to 1 over x? What is the graph look like? The graph looks like this, right? So you have your y-axis, and then you have your x-axis, and then you have one piece over here, and then you have one piece over there. What's happening in the y-axis? When x is equals to 0, there is a vertical asymptote. So that means you cannot plug in 0 to the function because 1 divided by 0 is undefined. So that means f of x is not continuous when x is equals to 0 because at that point there is a vertical asymptote. Okay, so let's take a look at the last graph. So we have a dot. So when x is equals to a, y is equals to f of a. So we have a dot right over there, and then we have a left limit as x approaches to a from the left. The limit is equals to f of a. How about the other one? As x approaches to a from the right, what is the limit equal to? The limit is equals to f of b, right? So this one, let's follow the color code. So it looks like for the right limit, so limit as x approaches to a from the right, from this direction, of f of x. So what is that equal to? That is equals to f of b, right? So what does that mean? That means the function is not continuous when x is equals to a, because you have to pick up your pencil one time to finish the curve. So when you sketch this curve, you start from the left. So from the left hand side, you start right here, and then you have to pick up your pencil, you draw an open circle, and then you sketch the rest. So since you already pick up your pencil to finish the graph, then the graph is not continuous at the point where you pick up your pencil. So let's write the left side limit as well. I will follow the color code. So limit as x approaches to a from the left of f of x. So this is equals to f of a. But the other one is f of b. F of b and f of a, they are two different y values. That tells me the curve, they are broken into two pieces at x equals to a. Therefore, the curve is not continuous at x equals to a. Alright, so let me give you a few more information because before we conclude this video. So the next information that I want to show you is polynomial functions are always continuous at every real number, because the functions are always defined for any x value. So I have two polynomials for you. The first one is in red. So f of x equals to x squared minus 4x plus 5. That is a quadratic function. And then for square, we have a parabola. And then the domain of the parabola is all real number, right? X can be any number you want. Just think about this. You don't have any denominator. You do not have any square root, you do not have any logarithm, so x can be any value you want. 0, positive, negative, it doesn't matter how big or how small it is. So that means x can be any real number, so you can sketch the entire curve without picking up your pencil. So therefore, for the first graph, we say that the function is continuous at any x value. Any. You can plug in any value you want. You will not see any open circle, you will not see any vertical asymptote. Alright? How about the second one? The second one is a third degree polynomial, and then the domain is, of course, is all real number, because there is no ln, there is no log, and there is no radical, there is no cube root. The x, you can let x be any value you want. So that means you can sketch the entire curve without picking up your pencil. You can try that really quick. Sketch the entire curve without picking up your pencil. So therefore, we say that x is the function is continuous at any x value. Alright, so no vertical asymptote, no discontinuity. So if you go back to the previous picture, the one that you are looking at on the right hand side, we say that the function is not continuous when x is equals to a, because at x equals to a, look, the function is broken down into two pieces. So unfortunately, the function is not continuous when x is equals to a. Alright, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, click the subscribe if you're on your way out. Appreciate for your help. I will see you all in the next one. Signing out.